Hello, lovely people. This is Demystified Mathematics by Boss Willis. Today we continue with our series, How Prepared Are You? Let's start off with question number one. Now we have a question on inequality. So, this question, the first thing that you are supposed to do is you are supposed to expand. So, I'm going to get this expression is greater than this plus this. You are going to get x minus 4. So, you try and group the quadratic on one side. So, here 2 minus 3. When the 3 comes, it becomes minus. So I'll get negative x squared. When the x comes here, it becomes minus. So I'll get minus 6x. When 4 comes here, it becomes plus negative 12. So that would be negative 8 is greater than 0. So if I multiply throughout by negative 1, I am going to get this. However, because I'm multiplying throughout by negative, the inequality sign will change. It becomes less than. So here I have a minimum quadratic curve. Okay. How do you know it's minimum? The coefficient of s squared is what plus. So this is how it will look like. So plus, that's the sign here. So the shape is going to be like this. So this is a minimum. If it was negative, it would be negative. The coefficient will be negative. It looks sad, eh? And this one looks happy. So this is a minimum curve and this is a maximum curve. So the sign, the coefficient of s squared will show you whether it's like this or like that. So now let's solve this quadratic quickly and see what you are going to get. Now x times x will give me x squared, and 4 times 2 will give me 8. I'll come back to the inequality. Right now I'm just trying to find the factors, or what we call the critical values. So here, if I want to get plus 6x, I will add the two of them. I'll add the two of them. So I'll bring the same operations here. This is a short way of solving quadratics. So now the expression here becomes my linear factors. So now I reintroduce my inequality sign. All right. So now there's something interesting about quadratics. If you have less than, that's your final quadratic, not from the beginning. You see, here I've simplified it. I've gotten a final expression. So if you have less than, in my previous video, I said that you are going to get, and you are going to get two values for x. It's going to be less than, where the small value comes first, then the big value follows. However, if it is greater than, then the big value goes with greater than and the small value goes with less than. It works every time, but provided that the quadratic is a minimum graph. That's the only time that this thing will work. I said it in the previous series. So here, I know my my critical values are going to be -4 and -2. So if I'm doing my inequality, it's going to be less than, because here is less than. Okay. So the small value is here is -4, and my big value is -2. All right, question two. Question two is a question on quadratics. Now, they say we should write it in this form. All right. There are so many ways of doing this. You can use completing squares, you can use expansion, or you can use differentiation. But because most of you have not done calculus, the I would rather recommend that we use method of completing squares. Now, mind you, in 2025 May June, they restricted them to method of completing squares. So I always encourage my students to learn new method. All right, don't be too fixated on one method. Learn, open up and learn new methods. So here I'm going to show you the method of completing squares. So the first thing that you do is that you have to make sure that the coefficient of x squared is 1. How can you do that? You have to factorize the 2. This 2, you have to make it come out. So if I make it come out, 2 times x squared is 2x squared. All right. Then in order for me to get x here, I'll just write x over the factor, which is what, 2. Let's multiply into whether to give us x. This times this, you should get x. All right. Then the same thing, 15 over the factor here. Not difficult, right? Now, the next thing that you do is that you just open bracket like this. Then you put square here. Then you write x. Every time you write x, open bracket, you square here. Then the next thing that you do, the coefficient of x is half. Is half. So every time you just multiply the coefficient of x by half. So this will give you 1 over 4. And it's positive, positive 1 over 4. If it was minus, you bring minus 1 over 4. Then the number that I've gotten here, this number, you just bring the same thing here. 1 over 4. You square it, then you subtract. It's always subtraction, eh? You square it and you subtract. Then you bring the number here, the constant. Bring the constant down. Like that. That's it. That's the method of completing square. It's done. The rest is calculation. So this will give me this is the same as 1 over 16 by being negated minus 15 over 2. Mind you, um, I can write this one as I want to have them to have the same denominator, so it becomes easier for me. So this is the same as -1, the numerator 15 times 20. Because it's per one, you're not supposed to use calculator, so you are supposed to be very smart. 15 times 20, I think it's 120. 120, yeah. So you are going to get minus, the numerator is minus 121 over 16. Now I just multiply this one by 2. Then I multiply this by 2. So here the 2 and the 16 will cancel. So it will be over 8. Right. So I have express my answer in the vectors form. This is the vectors form. You can see where they say that where a and b are exact constants to be found. So I'm supposed to find the value of a and b. So a here is the same as what? This one, 1 over 4, and b is negative 1 to 1 over 8. Now, it's not every time that they will tell you to find the values of a and b. If they don't tell you to find it, please leave it like that. Other than that, it's just a waste of time. They will not award any marks for that. All right, now, hence, write down the stationary point. Please don't forget that stationary point is the same as turning point. Don't let that word scare you. It's the same as turning point. So the turning point constitutes the x value here. You just take the value here, which is 1 over 4, then you negate it. Every time you take the value here, then you negate it. Then the y value here. For this one, you don't do anything to it. It's the same. The same as negative 1 to 1 over 8. Now, sometimes the question will tell you that find this is a minimum curve. They can tell you to find the value of the function or they can tell you to find the least value of the function. It will be this one, the constant. Okay. And the value of x at which it occurs, which is negative 1 over 4. So they can ask you a question like that. Now let's proceed. Now on the axis, sketch the graph stating the coordinates of the point where the graph meets the coordinate axis. The coordinate axis is the same as the x and y axis. All right. So now let's sketch this one quickly. We know the shape already because it's positive, right? It's positive, so it's going to look like this. Now I'm supposed to know my x and y intercept. The y intercept is the number that stands alone every time. So here is the y intercept is negative 15. Now the x intercept, you just solve the quadratic quickly. 2x squared plus x minus 15 is equal to 0. 2x times x will give you 2x squared. Then 5 times 3. This is more of a try and error method, but it works if you're going to get whole number or fraction every time. It does, unless you're going to get a set. That's when it's recommended that you use a quadratic formula. So here is plus minus. This will give me x, which is the same as the x here. So the same operation, plus minus. So my x value is negative 3 and 5 over 2. Those are my factors. So negative 3, let's say negative 3 is here. 5 over 2 will be closer. Mind you, your graph must look reasonable. So now the turning is between these two numbers. Okay. The turning is between the two numbers. It doesn't just turn anywhere, it turns between the two of them. So the middle, in other words, the midpoint of the x-intercept. So this is where the turn okay. But many students turn it at the y-intercept, which is not true. So you have to be careful. The turning is between the x-intercepts. So the midpoint of the x-intercept. Good. So some students, when they are giving their graph, they just, if they want to find the stationary points, the x coordinate, they just sum this one up, the x intercept up. This is the same as 2.5, and divide by 2, because that's will give you the x coordinate of the midpoint. You can confirm and see. This is the same as all right. So now write down the value of the constant k for this equation, and when it has three distinct solutions. So when it has three distinct solutions, this is how to check. Just draw a horizontal line through the graph. Let's test this side and see whether it will work. Does it favor us here? This is when it has four distinct roots. That's when it's between the y coordinate of the turning point and zero. So it's not it's not this point. What about here? Okay, so here it has three solutions. It's going to have three x values. Okay, if you map them, you see that it's going to have three x values. It has three different roots, three distinct roots. All right. So always when it is on the turning point, the horizontal lines on the turning point like that, that's when you're going to have three distinct roots. Mind you, it's just the y coordinate that you need. So k is equal to the y coordinate, which is what, 15.125. Or you can just write this. Don't write the two of them for me. Just choose one. Choose one of them. All right. So I'm going to choose this one. So that's it. Question 3. We are to sketch a graph, a cubic graph. Now, the first thing that you're supposed to do is to you can either find the x or the y intercepts. Okay. Now, so here, the value here is going to be, you just take this one, equate each of the factors to 0. So here, the x value will be 2, -1, then you get 3. Then the next one, you find the y-intercept. At the y-intercept, this is 0, this is 0, this is 0. So I have -2 times 1 times 3, which is -6. Now the shape of your cubic curve depends on the coefficient of coefficient of x cube, whether it is negative or positive. Now let's check whether this one is positive or negative. X times negative x. So it will be here, right? Now, if it's negative, it's going to start by going down and end by going down. That's to start on a negative note and end on a negative note. Let me bring it here so that you can see properly. Then if it were to be positive, it will start by going up and end by going up. To start on a positive note and end on a positive note. So this is how the shape of our graph is going to be. So I'll go like this. 10, 10, 10. Nice, beautiful, gorgeous. Is my graph not pretty? Please take note that the graph turns between the values, the two values, the two x values here. Between here, it will be between 2 and 3. So this is where it will turn. It should turn in the middle. It doesn't just turn anywhere. When you are marking, you check whether it turns, which quadrant it turns. Here it turns in the first quadrant, and also this is the fourth quadrant. It turns the fourth quadrant as well. So where it turns is important. All right. Now, when you are done, you are being asked to do one simple thing. They say show, or hence write down the values of x. Whenever I see hence, that means you're supposed to use your previous answer. So yeah, I'm going to use the graph. So here, f of x is greater than 0. So they are referring to the part of the graph that is greater than 0. This side and this side. All right. So for this side, it's between 2 and 3. And I say whenever you have between, then it is less than, less than. So here it's going to be between 2 and 3. So wherever you see the word between in math, that's less than, or less than or equal to. Mhm. Here, the graph is going towards the left. You can see it's on the left side. So the arrow here, the same, use the same sign for your inequality. The arrow head here. That's how they got the inequality sign. So here is what the value here is -1. So you just put -1 here. Make sure you clean this thing when you are done. It's just guiding you. My bad. All right. Question 4. Given that the coefficient of x squared in the expansion of this is 25 on 4, find the value of the positive integer n. It's a positive value. All right. Now, the first thing that we can do here is that we are going to expand this one. 1 minus x on 2 all to the power n. I told you in the other video that if you're expanding a binomial, then it starts with 1. The first term will always be 1. The second term is n combination 1. Then the power of this is n minus 1. The power here is 1. The same thing again. The power here will be what? 2. The same as the number here. Alright, you can see the same as the number here. So here, if you work this one out, you're going to get 1. N combination 1 is n. This will give you 1. And here you're going to get this. This is the same as n into bracket n minus 1 over 2 times 1, which is the same as 2. And this will give you x squared over 4. So I'm going to have 1 minus nx over 2 plus this. So this is my expansion. All right, now when you are done, your expansion is being multiplied by this expression. So let's bring my expansion here, binomial here. This is my expanded binomial. All right, so now we are looking for the coefficient of x squared. Well, you don't need to expand everything to just waste your time because the question is just 5 marks. So what you do is that you just scan, look at it carefully with your eyes. You can just gauge, look at it carefully and see. So here, 1 times 1 will not help me. It doesn't give me the coefficient of x squared. 1 times this, I still have x. But 1 times this expression is this x squared. Have you seen? So I've gotten the coefficient of x squared. But I'm looking for the coefficient of x squared. So let me take the x squared there out. I'm focused on the coefficient itself. Here, this times 1 will not help me. This times this will help me. Look at this. It will give me negative n x squared over 2. Once again, I'm interested in the coefficient, not the whole thing. So that's it for the coefficient of x squared. But that one is equal to what? 25. 25. So 25 on 4. I can multiply throughout by 8. If I do so, I'm going to get 4n. This times 8. Cancel. 2. Okay. So that will be 2 times 25, which is 50. You can clearly see that you're getting a binomial here. No, I mean, you're getting a quadratic. N times n is n squared. This times this. All right, so you're going to get n squared minus 5n minus 50 is equal to 0. So when I solve this, n times n will give me n squared. Let's do 10 times 5. This times this. What can I do to this 2 to get the middle term here? When it's minus and plus, I get negative 5n. So I bring the same operation here, minus plus. So my two factors are this and that, and everything is equal to 0. So n is equal to 10 or n is equal to negative 5. Obviously, they said that the positive integer, so n is equal to 10. Please, you have to conclude, otherwise you will not get the final mark. Question 5. Question on polynomial. All right, now they say that a and b are factors, sorry, a and b are constant, and it has a factor x plus 4. So when x plus 4 is a factor, then x, that means x is going to be equal to negative 4, right? So I'll put this one. If I put that value in my polynomial, I should get 0. So now let's try this one and see. I'm going to put it here. Let me squeeze it a little bit. Let me save this one here. This might be helpful for me later. All right, so I'm going to put in negative 4, negative 4, negative 4, and everything should be 0. So this will give me negative 64a um, 16b positive 76 plus 4 is equal to 0. So here I'm getting negative 64a plus 16b plus 80 is equal to 0. Let me divide throughout by 16. It will make my work easier. So this will give me negative 4a plus 1. Oh, there's b here. Okay, b. So that's b plus b. This one divided by 16 is 5. It's equal to 0. All right. So we know that if this one comes to the right hand side, that will be negative 5. So let's call this equation 1. Now, when I have this one, p of 1, let's see. Okay. This question will take your time. So 1, 1, 1. This will give me, when I finish, I'll multiply by 2. So don't worry. Let's do it step by step. This will give me a plus b minus 19 plus 4. And this is the same as negative 15. So now let me multiply by 2. Let me multiply throughout by 2 and see what I'll get. 2a plus 2b minus 30. All right. What if is this one p of 0? If I put 0 here, if here goes to 0, here is 0, here is 0. The only thing I'll be have left is 4. And when I finish, I multiply by 5. So 5p of 0 is 5 times 4 is what? 20. Yes. So now I can solve this one, this equation. I can connect them. So that means that 2a plus 2b minus 30 is equal to 20. So when this one comes here, it's 50. Okay, I can divide throughout by 2. So this will give me a plus b is equal to 25. Equation 2. So what can I do? Let me do equation 1 minus equation 2 and see what I'll get. So negative 4 minus a. Negative 4a minus. So that would be negative 5a. B minus b, 0. Negative 5 minus 25. So that's negative 30. So a is equal to 6. From here, from equation 2, if a is equal to 6, then b will be 25 minus 6, which is 19. All right. So yeah, hey, we are not done. Oh. They say we should show that p of x equal to this. What I've done is I've found the values of a, b. Okay, so now let me write my polynomial. So a is 6, b is 19 plus 4. All right. Oh, then the space was not enough for this amount of work. All right, but you can use the syntax method to factorize this one to find your quotient. It is very easy and fast. All right, so now let's take the first number. Let's start with the coefficients of the polynomials. This 19, negative 19, 4. And you know one of the factors, that's the good news. One of the factors is this. So you're going to go for the x value of the factor. And we all know that that will be what? Negative 4. So negative 4. So the first thing that you do is that you pull my friend here, you pull him down. So it comes here, 6. Every time you put the first coefficient down. So this times this, what will you get? Negative 4 times 6. You get negative 24. So the value that you get, you put it here. Then you add 19 plus this, you get negative 5. Negative 4 times negative 5. What do you get? You get 20. So you put that value here. Then you add this and this again. This will give you 1. Negative 4 times 1. That will give you negative 4. So if you add this one, the last number here is there. Is the remainder. So indeed, it even shows you that our factor is 0. I mean, our remainder is 0. So that means x plus 4 is a factor. All right, so we are in safe hands. So the factor times the quotient. This becomes the quotient. The number here becomes a quotient. However, you must always make sure that it is in the simplified form. What do I mean by that? That they don't have any common factor. If they have a common factor, it's simplified. So yeah, this is going to be my quotient. So they say I should write it in this form, yeah, where A, B, C are to be found. A is 6, B is negative 5, and C is 1. It can be for more hard, all these things for 6 marks. All right. So now the final one, they say I should factorize this. All right. I'm not supposed to write here, so let me cut it. So P of X is equal to, all right. So when you finish, say factorize this. So this becomes very easy. Basically, you're going to work on the quadratic. You can break the quadratic down. So this is the same as 3x times 2x. It will give you 6x squared, right? 1 times 1, you get this. So now let's cross this one. I'll get 2x. Let's cross this. I'll get 3x. Minus minus. This will be the same as negative 5x if you sum them. So I bring the same thing here. So my factors are this. Question 6. So let's say this is the straight line is equation 1 and this is equation 2. Now let's put equation 1 into 2. Don't forget that the y here is this. So let me make my presentation good. Put 1 into 2. So wherever you see y, you put this expression there. It's equal to 8. So I'm going to solve this Now you can see here that if you don't love quadratics, you are going to have a lot of headache here. It's all over the paper. So for paper 1, you have to master solving of quadratic functions. So here, this is the same as 5x times this, I'll get 5x squared. Should we do 4? Yeah, it will work. This time this, I'll get 10x. This time this, I should get 4x. What can I do to these two to get the middle number or expression here? When it's plus minus, this will give me 6x if I add them. So the same operation, I bring the same operation here, plus minus. So x is equal to -2 or x is equal to 4 on 5. When x is equal to -2, y will be from this side, from equation 1. This is -10 plus 6, which is -4. I can call this one a. When x is equal to 4 on 5, okay, so my b is 4 on 5, 10. Find the coordinates of the point where the perpendicular bisector of AB meets the line y is equal to x. So you're going to find the perpendicular bisector of AB. First of all, A is -2, -4, and B is 4 on 5, 10. So perpendicular bisector, I need two things. I need the gradient of AB to help me to find the perpendicular bisector. So gradient here is the same as -4 minus 10 over -2 minus this is the same as 0.8. So this will give me -14 over -2.8. The negative and negative will cancel out. So you're going to have 14 over. This is the same as 28 divided by 10. So if you solve this one, you're going to get 2 can go here, 7. 2 can go here, 4, 8. My bad. What am I thinking? They can just cancel straight. This can go here 1. This can go here 2. This can go here 1. This can go here 5. So you get 5. So the gradient of AB is 5. So now the gradient of my perpendicular bisector is going to be the negative reciprocal of this. So this is the same as 1 over 5. Then I negate it. Then don't forget that you're supposed to also find the midpoint. Midpoint of AB. So I sum this one up. Negative this plus 0.8 over 2. This plus this. Okay, so this will give me negative 2. Sorry, this is the same as negative 1.2 over 2, then 6 over 2. So if you solve this, you're going to get negative 0.6, and this will give you 3. So this is the same as negative 3 um, on 5 comma 3. Now equation of the perpendicular bisector. So now your y coordinates of the midpoint is 3. Your gradient is negative 1 over 5. And your x coordinate is this negative 3 over 5. So if it comes, it become negative negative, which is positive 3 over 5. Yeah. Okay, we are not done. Let me create a little bit space for myself. All right, now when you finish, they say that that perpendicular bisector meets this line. So that means that the two of them can be solved simultaneously. So I can say this is equation 1, then this is equation 2. So I'm going to put 2 into 1. Let's see what will happen. So that means wherever I see y, I put x there. Here's already x, so I can go ahead and expand. This times this, I'll get negative 3 on 25. So let's solve this one some way and bring it back. So when this one comes, it's x plus 1 over this. Then this is 3 minus this. So this should give us 6 on 5x. This is 75 minus 3. 72 over 25. 5 can go here 1. 5 can go here 5. 6 can go here 1. 6 can go here 12. So x is equal to 12 on 5. So the point will be x is equal to 12 on 5. Now from equation 2, we know that x and y are the same. So that means if x is 12 on 5, y will be 12 on 5. Question 7. Find the values of k for which the straight line and the curve do not intersect. So the first thing that you do is that um, you have to solve them simultaneously, right? You know the expression for y. So wherever you see this y, you put this value there. Okay, let me bring them here. So it's going to be 8x minus kx. When this one comes here, plus 7 is equal to 0. So they say they don't intersect. That means that if this is the straight line, this is the curve. So if you have this situation, that means your discriminant is less than zero. Your discriminant is less than zero. So you are going to get complex roots, in other words. So my A is 3 and my B is 12. When I solve this, I'm going to get hmm, this is minus 144 is less than 0. Okay, so here I want to I want to find my critical value. And if you find the critical value, you're allowed to use the equal to sign. And when you finish, you come back to the inequality. Or better still, let me just do my normal expansion. Okay. This minus this, um, I'll get minus 80. Okay. Now let's solve this quadratic. Okay. Because this one is huge, I want to use the quadratic formula. Negative this minus 16 squared. Oh, that's going to be huge. No. Let me just think my way through. Okay, now let me just use my normal method. K times K will give you K squared. 20 times 4 will give me 80. Okay. This time this I'll get 20K. This time this I'll get 4K. What can I do to these two to get the middle term here? When here is minus plus, I'll get negative 16K. So I bring the same operation here, minus plus. So my factors are this. So in other words, my critical values are negative 4 and 20. So for inequality, if you have less than, don't forget that I said it's going to be less than, less than. So the smaller value is negative 4 and the big value is 20. So that is going to be my values for K. Number 8 is on logarithm. Find the value of this. So this is the power. Your power can be written, can become your coefficient. So, and any logarithm to the same base is 1. So the whole thing here goes to 1. So it's the same as negative 2 times 1, which is what? Negative 2. What about this? So this is the same as, can be written as this from indices. Do you remember? So here, and don't forget that LG means like logarithm to the base 10. So this is the same as negative n log 10 to the base 10. And this one is the same as 1. So this is the same as negative n times 1, which is negative n. Show that this is equal to this. All right. Okay, let's see. So for the numerator, they are subtracting, right? Let me just solve the numerator separately. This is the same as, so if they are subtracting and they have the same base, that means you can just divide the argument. So 20 over 4, and this will give you log 5. And for the denominator is this one. Okay, so we can change the base here to base 10, right? And it's the same as logarithm, logarithm. Then you bring the argument over the base. We are changing to what base? Base 10. So I put 10 here, 10 here. So this is the same as 1 over log 5 to the base 10. So now this is the same as, so the numerator, don't forget that your numerator is what? Um, your numerator is log 5. Let me use LG. And your denominator is 1 over log 5. This is the same as log 5. So here, so this is, if they are dividing, you find the reciprocal when you multiply. It's equal to this. So this will give you log, yeah. Okay. And in indices, if your powers are the same and you have a single um, index form, or in this case, you have a single logarithm here, single logarithm here, then you can just equate the two of them. All right. So here I can see that y is equal to what? I can see log. You can just equate the bases. Log 5 is equal to log y. In other words, if I take the anti-logarithm, y is equal to 5. IV. All right. So here they have the same basis. So when we know that if you have logarithm and they have the same base, you can just, and they are adding, you can just multiply the argument. So this is the same as 6x squared is equal to this. So I can take the anti-logarithm of both sides, or I can just say that the argument will be the same since they have the same logarithm to the same base. Okay, 6 can go here 1, 6 can go here 100. I'll take the square roots of both sides. This will give me plus or minus 10, and x will be positive 10 because the argument is always positive. Okay, so please, therefore the answer is supposed to be positive 10. All right, question 9. So this is a question on modulus graph, but in this case they have drawn the graph for you. You have a modulus straight line graph, then you have a straight line as your g of x. Now it's a final expression for f of x and g of x, but they want the modulus function for f of x. Okay, if I take this graph for instance, originally it's originated from, it came from this side, And the point is what? The y intercept is what? -3. So the y-intercept is -3 and the x-intercept is 1. That's the original straight line. Okay. So here I can see that the y-intercept is is um is what? That's the value of c is -3. I'm going to use this equation y is equal to mx plus c. Now, what is left for me um, is to find the gradient, which is not going to be difficult because I can use the x-intercept. At the x-intercept, what happens? At x-intercept, that's when x is equal to 1, my y is what? 0. I just need a point, all right? Now come and put the point into this equation. When y is 0, my x is 1. So my ingredient is going to be, when this one comes, is 3. So my m is going to be 3. So I'm just going to put it here, 3x minus 3. All right. So the modulus function is simply going to be 3x minus 3. Well, they're going to have two possibilities. It's either the graph goes like this or it comes like that. So you can also find when you have this line, but I prefer to use this one. All right. What if you have g of x? For g of x, that one they have drawn it's just a normal straight line, so it's even easier. G of x. So let me see whether I have some space here. Now your g of x, your x-intercept is what? 3, 3, 0. For your y-intercept, you already know that it is 3, so you don't need to calculate for it. So you are going to have something like this. So you just put the point here, 0. The gradient is, you don't know, your x is 3. Okay, so if you solve this one, you're going to get um 3m. When this one comes here, minus 3. So m is going to be -1. So your equation is going to be -x, and your y-intercept is what? 3. So that's it. So this is going to be your g of x. Mind you, it is positive. My y-intercept is positive, so here it's positive here. Okay, so I'm going to solve these two. I'm going to solve these two equations. That's what they said in the B parts. I mean the follow-up question. Oh, it's less than. So I have something like this. It's less than this. So first of all, if you are solving, you just do your normal. So when this one comes, you get 4x. You find your critical values. And I told that if you are finding your critical values, you're allowed to use the equation sign, equal to sign, right? So here, when this one comes, you get 4x. When this one goes here, you get 6. So x is equal to 3 on 2. Then there's another possibility where the whole thing is negated. So this will give you x minus 3. All right. So when this one comes, you get 2x. When this one comes here, you get 0. So x is equal to 0. So, but since it's less than, don't forget that you're going to get less than, where the small value comes first, which is 0, followed by the big value. Yeah. And your answer is reasonable because if you look at the graph carefully, you can see that where they meet, where they intersect, that's where the solution is going to be. One of them is 0, and the other one is going to be somewhere here. But it's very difficult to just look at it and point it out. So here, this will be the difficult part. So here will be 3 on 2. So it looks reasonable. Question 10. You have been given this. Question 10. You can apply trig identity. Question 10. Okay, you have been given this expression for y, this expression for x. Express y in terms of x. All right. So, and there's a connection between sec theta, sec square theta, and tan square theta. If you have forgotten, just go back to the formula formula sheet. I know, but I just want to, quote it for you. So you can see it here, right here. But in this case, our angle is theta. So let me use theta. So I'm just going to apply it here. So you have the value of sec. You can find sec square theta from here. Sec square theta is going to be y over 2. Then also, if you want to find tan theta is equal to, when this one comes, is x plus 5. So tan theta is x plus 5. So here it's being squared, so you just square it. You have sec square theta here, which is y over 2. So if I make y the subject, I'm going to multiply throughout by 2. So I'll get this. 2 is equal to, everything is equal to y. So that's it for 2 marks. Question 11. The coordinates A, B, C are 6, 4, P, 7, 14, 18 respectively, where P is a constant. The line AB is perpendicular to BC. Given that P, the value of P is less than 10, find the value of P. All right, so I will start answering this question by drawing a circle. Now, there's point A, let's say point A is here, let's say point B is here, and point C. Now, they say that AB is perpendicular to BC. That means AB and BC meet at 90 degrees. And we know that there's a theorem that says that the diameter makes an angle of 90 degrees at the circumference. That's angle in a semicircle. All right. So now if they want me to find the equation of, if they want me to find the value of P, I can find the gradient of AB and also multiply it by the gradient of BC. And we know that there's a principle that says that if two lines are perpendicular, if you multiply their gradients, you get -1. So let's take the gradient of AB. This is the same as 4 minus 7 over 6 minus P. Then for BC, this is the same as 7 minus 18 over P minus 14. Okay, so the numerator is going to be -3 times this -11, and I can multiply this. This will give me 6P minus 14 times 6, 84. Then -P times P, I'll get minus P squared. Then -P times this, I'll get 14P is equal to -1. So now this is the same as -33 over, this can be written as -P squared 6 plus 14, 20P minus 84 is equal to -1. So it's an expression, so I put this one in the bracket. So this is the same as, you can cross multiply this. So this is the same as -1 times this whole expression. My bad. This side is supposed to be 33, not -33. Yeah. So I'm going to get 84, 84 minus 33, which happens to be 51. So P times P will give you P squared. 17 times 3 will give you 51. This time this I should get 17P. This time this should give me 3P. What can I do to these two to get a middle number here? When it's minus minus, so minus minus. So P, these are the expressions you get. So P is equal to 17 or P is equal to 3. However, they say that our value is less than 10. So therefore, the value of P is 3. Given that the circle passes through ABC, find the equation of the circle. So that's the follow-up. They want us to find the equation of the circle. All right. I'm very sorry for the noise in the background. There's some construction going on here. All right, so AC, you can find the midpoint of AC. Our A is 6 4, and C is 14 18. So we can find the midpoint, which happens to be the same at the center. So this is 20 over 2, which is 10. This is 22 over 2, which is 11. So that's the center. Let me call it M. So now I can easily find the equation because I can easily find the radius. The radius is the same as um, the length of AM, or you can choose MC. Any of them is correct. So I can have 10 minus 6 squared plus 11 minus 4 squared. So this should give me 4 squared. This is 4 squared, which is 16, plus 7 squared, which is 49. So this will be the same as square root of 65. And we know that we can't break this one down, right? But we are rather interested in r squared. So if I find r squared, I square both sides, I'll get 65. Why am I finding r squared? Because I know that the equation is this. This is the equation of the circle. So the center is what do you have here? 10 and 11. So here r squared is 65. So I found it directly. So this should be the equation of the circle. 4 marks. Question 12. You have to solve this and find the exact value of cot x. So this is the same as 1 over sine x is equal to negative 17 over 8. So in other words, sine x equal to, if I find the reciprocal of both sides, I'll get this. So you can find the reciprocal of both sides, you get this. So in other words, if I should draw my in triangle. It should be in the fourth quadrant because this is the same as let me see, 180 over 2. This is the same as 270. So it's between 270 and 360. So I'm in this quadrant, all right? And we know that in this quadrant, the value of sine is negative. All silly tomcats. It's only cos that is positive. All of them are negative. So here, sine, this is 8, this is 17. So I can find the value of this. A squared plus a squared is equal to 17 squared using Pythagoras theorem. So 17 squared minus a squared, if I solve this one, I am supposed to get 15. So I can now find the value of cot x. Cot x is the same as 1 over tan x. And we know that tan is what? Tan is going to be tan is going to be y over x. That's 8 over 15. All right. And we know that if you have 1 over a fraction, it's simply the reciprocal of that fraction. But the question is it going to be positive or negative? And why? It's going to be negative because all silly tomcats, it's only cos that is positive, the rest are negative. So tan 2 will be what? Negative. So cos is a function of tan, so it's going to be what? Negative. All right, so more trick for us. Prove that this expression is equal to this. Now tan theta. All right, so here I'm going to break all this one into sine and cos. So tan theta is the same as, I want to solve the numerator separately and the denominator separately. It makes it easier for me. So this one is the same as sine theta over cos theta. Let me create a boundary. So if I solve this, I'll get sine squared theta plus this times this cos squared theta over sine theta cos theta. Okay. Then, so this one goes to 1. So this is the same as 1 over this. That's for the numerator. Now, the denominator, you have 1 over cos theta plus 1 over sine theta. So you just cross multiply. This time, this you get sine theta plus cos theta over cos theta sine theta. All right. So when I finish, it will be numerator over denominator. All right. So therefore, this is equal to 1 over. Let me come down here. This and this can cross out. So I'm going to have 1 over sine theta plus cos theta. Why did I cross this and this out? Because it's dividing. And so if you find the reciprocal and becomes times, this one will cancel this. This becomes the denominator. This one becomes the numerator. They'll cancel out. C. Given that tan x is equal to this, find the exact value for sine x and cos x. All right, so this is from 90 to 180. So that means I am in the second quadrant. All right. So the reason why it's negative is that tan has a negative value. Tan x has a negative value in the second quadrant. So here, the y is 5 and the x is 12. So the value here. So I know r squared is equal to 5 squared plus 12 squared. So if I take the square root of both sides, this will give me 13. So if I want to find the value of sine x is going to be 5 over r. R is what? 13. Mind you, sine is positive in the second quadrant. It has a positive value. What about cos? Cos will be x over r but the value here is negative. Cos has a negative value in the second quadrant. Question 13. Find the first term in a GP is 10. All right. First term in a GP is 10. All right. GP and AP. The first term is 10. The GP has a positive common ratio. Okay, so the common ratio is positive. The first term of an AP is 10. The AP has a negative common difference. So the common difference is negative. All right. The second term of the GP is the same as the fourth term. Okay, so this second term is equal to the fourth term here, and the third term of the GP is the same as the C term. So U2 of the GP is equal to U4. Now, for a GP, the second term is AR, and for an AP, the fourth term is A plus 3D. Mind you, the value of A is 10 for both of them. So 10, okay. All right. So I can call this equation 1. Now, we also know that U3 is equal to U6. So U3 in the GP is AR squared, and U6 is the same as A plus 5D. So here is 10 R squared is equal to 10 plus 5D. All right. But don't forget that I can write this one as 10 R multiplying R. Okay, indices R times R is R squared. Let me call this one equation 2. Now I can put 1 into 2. What is 1? Your equation 1 is um, the same as the expression here. Can you see? So that means I can put this whole thing here. So this is the same as 10 plus 3D multiplying R is equal to 10 plus 5D. So here I'll just make out the subject. If I make out the subject, I'm going to have this. Let me create a space for myself. If possible, always divide your thing into 2 so that you can have enough space to work with. All right. So now here, I know the expression for R. So let me call this one equation 3. So I can put it in either 1 or 2. Let me put it in 1. 1 looks easier. From equation 1, or let me just say that put 3 into 1. Our R here, our R is what? 10 plus 5D over 10 plus 3D is equal to 10 plus 3D. Okay, so I can put this one in the brackets. Fractions. So you know this and this can cross multiply. So this by this, that's the same expression multiply the same expression. So that's the square root of that expression. So this I'm going to get a quadratic. Let's expand and see. So this will give me 100. This, I'll get 6d plus 9d squared. You have to be very careful here. That will give me 100 plus 50d. 100. This, I'll get 60d. 9d squared. So here, this and this will subtract. All right. So when I bring my friend here, 60 minus 50, that will be 10. 10d. So they have d in common. Okay. So d is equal to 0, or d will be equal to negative 10 on 9. Mind you, they have shown us how to choose between the two values. They said d is negative. So therefore, d is negative 10 on 9. So what will the value of r be? I can place it here, equation 1. From equation 1, we know that 10r is equal to 10 plus 3 multiplying d. All right. So 10r. So this will give me 10 minus 10 on 3. So if I multiply here by 3, here by 3, this will give me 30. 30 minus 10 over 3. So that's 20 on 3. 0 go here. 0 and 0 cancel here. 0 cancel here. So r is equal to 2 on 3. R is equal to 2 on 3. Your thing cannot eat into this space. So let me clean this side. This is never done. So you can't write this at this side. Now determine whether the GP has a sum to infinity. If the GP has a sum to infinity, down the radius, I mean the common ratio. The common ratio will be between -1 and +1. So since my value here, my common ratio is between this value, the GP has sum to infinity. All too soon, we have come to the end of this video. Don't forget to like and subscribe. Send the videos to your friends in different schools and different classes. I will see you in the next one. Bye.